In this video, we're going to look at how to perform binary shifts. Binary shifts allow us to multiply or divide binary numbers by powers of 2. When we shift to the left, we multiply the number, and when we shift to the right, we divide the number. Let's look at how we perform a binary shift to the left in order to multiply. Now, we need our whiteboard, and we need a binary number. We're going to use the binary number for 25 for this example. We're going to multiply this binary number by 8, which is 2 to the power of 3. This means we're going to need to shift 3 spaces left. The first 3 zeros that we see here are going to fall off the end, so we will remove those. The 1 from the 16 column is now going to shift 3 places to the 128 column. The 1 from the 8 column will shift to the 64 column. The 0 from the 4 column will shift to the 32 column. The 0 from the 2 column will shift to the 16 column, and the 1 from the 1 column will shift to the 8 column. The 3 empty columns 4, 2 and 1 are just filled with zeros. So if we convert this resulting binary number to decimal, we can see that the original value of 25 has become 200, which is 8 times greater as we expected. Now let's look at binary shifts to the right with another binary number. We're going to use the binary number for 84 in this instance. We're going to divide this binary number by 4, which is 2 to the power of 2, so we need to shift 2 spaces to the right. The 2 zeros at the end are going to fall off the end, so we remove these. The 1 in the 4 column will shift to the 1 column. The 0 in the 8 column will shift to the 2 column. The 1 in the 16 column will shift to the 4 column. The 0 in the 32 column will shift to the 8 column. The 1 in the 64 column will shift to the 16 column, and the 0 in the 128 column will shift to the 32 column. The 2 now empty columns of 64 and 128 will be filled with zeros. So if we convert our resulting binary number to decimal, we can see that our original value of 84 has become 21, which is 4 times smaller as we expected. We know how to perform logical binary shifts on unsigned binary numbers. But what about signed binary numbers? Signed binary integers using the 2's complement method reserve the most significant bit. 0 represents a positive number and 1 represents a negative number. When shifting right in the logical shifts that we've just looked at, the spaces left behind are replaced with 0. In the case of a negative number, this would turn the number positive, giving us an incorrect result. In this instance, we can perform an arithmetic shift instead. In this instance, the now empty most significant bit is replaced with the value that was originally there instead of always being replaced with a 0, so if it was a negative, that sign is retained. So when we are dividing negative numbers, we need to use an arithmetic shift instead of a logical shift to ensure that most significant bit is retained. We still cannot perform multiplication using left binary shifts on negative numbers, however, using either method because the most significant bit would not be maintained. So thank you for watching this video. If this video was useful, please leave a like, subscribe to see more computer science videos, and let me know any questions or requests for what I should cover next in the comments.